So GitHub recently gave its AI code reviewer this massive upgrade.
Oh, yeah.
Better visibility, cleaner shared tools, just a pristine workspace for it to operate in.
Right.
And the logical result you'd think would be faster, better code review. But instead, the AI actually became more expensive, vastly less helpful, and completely lost its mind.
It really did.
Today on the deep dive, we are exploring this crazy paradox. Like, why does giving artificial intelligence better tools actually break it? And how is the industry scrambling to build cages around these systems just to make them functional for you and me?
Yeah, we usually operate on this very linear assumption in software engineering,
Yeah.
like upgrade the stack, improve the output.
Exactly.
You give a developer a faster machine, the compile time drops, it's simple. But introduce autonomous agents into that environment, and that linear assumption just completely shatters.
It just doesn't work the same way.
No, not at all. We treat these systems as highly rational, hyper-efficient calculators, right? But their behavior under the hood is wildly unpredictable.
Okay, let's unpack this. Because GitHub runs this initial benchmark with the new cleaner tool set. The AI has everything it needs to perform like a flawless review,
Sure.
but the data shows costs go up and useful findings actually go down. So what is the actual mechanism causing that failure? Why does a cleaner workspace degrade its performance?
Well, it really comes down to how the agent chose to utilize that newfound visibility.
Yeah.
Normally, a code review starts right at the diff.
Right, the changed lines.
Exactly. You look at the pull request, you isolate the specific lines that change, and you work outward to see the immediate impact. But this AI agent, armed with its shiny new shared tools, just completely ignored the diff.
It just skipped it.
Yeah, it started browsing far, far too broadly across the entire repository.
So it had the keys to the kingdom and it just went exploring instead of doing its job.
What's fascinating here is the absolute lack of inherent focus, because the agent had the sophisticated tools to easily scan like every module and dependency. It got totally distracted by the entire architecture of the codebase. It lost the anchor of the actual task it was assigned. I mean, it had so much freedom that it lost sight of the pull request entirely.
Okay, I like to think of this like hiring a plumber to fix a leaky pipe under your kitchen sink.
Okay, yeah.
And because you gave them a master key to your house, they spend 4 hours inspecting your roof tiles and testing the insulation in the attic before even looking at the kitchen.
That is exactly what it's doing.
And you're paying by the hour. They're diagnosing structural issues you didn't even ask about. But wait, let me push back on this a little bit.
Sure.
Isn't the whole point of an advanced AI to have this superhuman ability to analyze the whole system at once? I mean, why is browsing broadly a bad thing? Shouldn't it be checking to make sure the sink leak isn't somehow connected to a broader architectural flaw in the house?
I mean, in theory, systemic awareness sounds incredible. It is the holy grail of system design.
Hmm.
But in real-world application, unbounded AI browsing triggers two catastrophic failures.
Okay, what's the first one?
First is the skyrocketing computational cost. Every single time that AI reads a file, processes a legacy dependency, or scans a distant module, it consumes compute tokens.
Which means real money.
Exactly.
Yeah.
You are burning through expensive processing power to analyze code that hasn't been touched in 5 years and has zero bearing on the current update. You are literally paying the plumber to stare at the attic insulation.
Right, which nobody wants. And the second failure?
The second failure is a severe dilution of insights. And this comes down to how attention mechanisms work in large language models.
So the model's context window just gets completely flooded.
Right.
It can't distinguish the signal from the noise anymore.
The technical term often used is being lost in the middle. When you cram a context window with 10,000 lines of irrelevant codebase architecture, the AI's attention gets distributed way too thinly across all those tokens.
It just loses track of what matters.
Yeah, so when it finally generates its review, it might flag 50 theoretical, low-priority issues in distant dependencies, but entirely miss the glaring off-by-one error in the 5 lines of code the developer actually changed today.
Oh, wow.
By trying to look at everything at once, it effectively sees nothing of immediate value. It just generates noise.
So the plumber hands you a 50-page report on your house's structural integrity, but your kitchen is still actively flooding.
Pretty much, yeah.
So GitHub's solution to this wasn't to revert the tools or dumb down the AI, but to enforce this highly rigid workflow. Here's where it gets really interesting, because they created what we are calling a practical contract to rein in this wandering AI.
Right, and it worked beautifully.
It dropped the average cost by roughly 20% while maintaining the exact same review quality. It's a highly specific 5-step workflow that acts like a straitjacket for the algorithm. So step 1 is simple, start from the diff.
Yeah, we are anchoring the model back to reality. By forcing the first step to always be the diff, you are providing the initial strict boundary for the context window.
Meaning, do not look at the whole house.
Exactly. Look only at the specific pipe that was just replaced. The diff becomes the foundation of every subsequent action.
Which brings us to step 2, which feels almost like cognitive behavioral therapy for algorithms.
That's a great way to put it.
Form a concrete review question. Before the AI even touches a search tool, it has to articulate what it is actually looking for.
This step fundamentally shifts the AI from a passive reader to an active investigator. It translates a vague directive, like, review this code, into a highly specific attention filter.
So it has to talk itself into focus.
Yeah, it forces the model to generate a question. For instance, does this new user authentication variable interact safely with the legacy database schema?
Got it.
By generating that specific question into its own context window, it primes its neural network. It weighs tokens related to database security much higher than tokens related to, say, front-end UI styling.
It creates its own internal relevance filter, which is heavily utilized in step 3, gather targeted evidence. Now that it has a concrete question, it executes a surgical strike for data. But how exactly are they enforcing this? Like, how do you stop a large language model from just reading the whole file anyway once it finds a piece of evidence?
Well, the orchestration layer handed that restriction. The underlying system doesn't just hand the LLM a generic read file command and hope for the best.
Okay.
It restricts the parameters of the tools the AI is allowed to call. The AI is forced to use tools that fetch specific snippets, or grep, for exact function definitions.
So it can't just gorge on the whole document.
Right. If the AI asks for a file to check that database schema, the orchestration layer might only return the lines immediately surrounding the keyword it was looking for, based entirely on that concrete question from step 2. It is a surgical extraction of data.
We are physically limiting its exposure to irrelevant information, which makes total sense of step 4. Read the smallest relevant range. It's all about extreme token efficiency. If you only need lines 40 through 50 to answer the database question, you do not pull lines 1 through 1,000. You keep the context window pristine.
Because every single extraneous token you allow into the prompt degrades the model's reasoning capacity on the primary task.
It dilutes it.
Exactly. Reading the smallest relevant range preserves the signal-to-noise ratio. It ensures that the model's compute power is entirely focused on the logic of the code change, rather than parsing, like the copyright header at the top of the file.
Right. And then we arrive at step 5. And honestly, this is the most crucial part of the whole contract. Step 5, stop when the evidence answers the question.
Just stop.
Just stop. We are managing a hyperactive detective who is undeniably brilliant, but will absolutely investigate a decade-old unpaid parking ticket if you don't explicitly tell them to close the case file once they find the murder weapon.
That's spot on.
You literally have to program the stop condition.
Because the stop condition fights against the very nature of a generative model. These architectures are built at their absolute core to predict the next token, right?
To keep talking.
To keep generating text, you keep connecting abstract dots. To an LLM, providing an endless stream of tangential information is being helpful.
Even if it's annoying for us.
Exactly. The human workflow contract forces a massive paradigm shift. It forces the AI to understand that in professional engineering environments, brevity and finality are the ultimate forms of helpfulness.
So it has to wrap it up.
It requires the model to evaluate its own gathered evidence against its initial concrete question and output a termination sequence rather than a continuation.
So we've essentially put a straitjacket on the AI's workflow to make it functional. But here's the terrifying part. Even if you control the workflow perfectly, Microsoft's latest Agent Evil guidance shows the AI can still completely derail if you don't meticulously control the room it's sitting in.
Oh, absolutely.
Controlling the workflow is only half the battle. Evaluating if the agent is actually performing well exposes a mind-blowing level of systemic fragility.
Yeah, human engineers expect testing environments to be deterministic. Like, a unit test run on my local machine should yield the exact same result on your machine, or in the CI pipeline.
Right, code is code.
But Microsoft's research into evaluating AI agents shatters that expectation. They identified chaos variables that will completely alter an AI agent's performance benchmark, rendering traditional testing methodologies totally obsolete.
And the list of variables they provide sounds completely inconsequential to a human developer. They're warning that outcomes shift based on the operating system, the specific shell being used, the file paths, and the user identity.
It sounds absurd, doesn't it?
Let's pause on that. The user identity and the file path. I mean, I can understand different tool versions causing a discrepancy, but how on earth does a file path change an AI's cognitive process during a code review? It's like a science experiment where the chemical reaction changes just because the scientist wore a different colored lab coat.
It really is. But it is critical to remember that an LLM does not experience a computing environment the way we do. It processes a serialized string of tokens representing that environment.
Okay, walk me through that.
So if an AI executes a shell command, and the terminal returns a prompt string that includes admin at server instead of test user at local, that text is ingested directly into the context window.
Oh, wow. It's less like a standard software test and more like a witness in a courtroom.
How do you?
Like, if the lawyer asks the exact same question but uses a slightly more aggressive tone, the witness gets defensive and subtly changes their story. The AI is reading the tone of the file path.
That is a brilliant way to frame it. The AI doesn't see a file path as just a location on a disk. It parses the semantic weight of the characters in that path.
It's reading the vibes.
Literally. If a folder is named tempfix v2 versus production release critical, the probabilistic weights in the neural network shift. The AI might interpret admin as meaning it has elevated permissions, boosting its confidence matrix, which alters the very next command it decides to synthesize.
It fundamentally overanalyzes the ambient text of its environment. It's reading tea leaves in the directory structure.
Microsoft's research goes even further into the weeds on this. They highlight that real-time language server protocol feedback, so the LSP errors populating in the background harness updates, and minor dependency states can drastically alter the trajectory of the agent's actions.
Stuff we'd normally just tune out.
Exactly. A human developer ignores a slightly reformatted error message from a background linter. An AI agent ingests that reformatted message as entirely novel semantic input. It wastes compute cycles trying to figure out why the error message has a different timestamp format.
That is wild.
If we connect this to the bigger picture, this is why Microsoft mandates a strict rule for any kind of AI evaluation. Because of this chaotic sensitivity to ambient tokens, every single benchmark must be accompanied by an environment manifest.
An environment manifest, what goes into that?
It is a cryptographic level snapshot of the entire workspace. It locks down the OS, the shell version, the exact file tree, the user strings, the LSP state. Everything. Without this manifest, comparing two benchmark scores is junk science. If your agent scores an 80 on Monday and a 60 on Tuesday, you cannot know if your prompt engineering failed or if a minor background dependency just shifted the ambient tokens in the environment.
It changes the entire paradigm of QA. We are no longer just testing code. We are essentially conducting psychological evaluations on algorithms. We have to meticulously control their physical reality so they don't get spooked by a weirdly named directory.
Exactly.
And building on this extreme fragility, it forces a massive rethink of system architecture. If we know the AI is this hypersensitive to its environment and wildly prone to wandering off into the attic if we give it a master key, how do we safely integrate it into a real-world software pipeline?
This raises an important question about systemic trust. Traditional software development heavily relies on the concept of a massive merge gate, right?
Right.
That final towering checkpoint where a massive batch of code is reviewed before being merged into the main branch and going live.
The ultimate bottleneck. One giant review to catch everything before deployment.
But the clear recommendation emerging from this data is to completely abandon the giant merge gate when deploying AI agents.
Really? Just get rid of it.
Yeah. Giving an AI an unbounded massive task like reviewing a complex multi-module merge all at once is begging for a hallucination cascade.
Because there's too much context.
Exactly. It maximizes the chance of the AI encountering an anomalous chaos variable, flooding its context window and losing its attention focus.
So the architecture has to be shattered into smaller pieces.
Yes.
Starting with what the research calls deterministic checks.
Deterministic checks are your hard, rules-based, non-AI tests. Compilers, linters, basic unit tests. They are binary and entirely immune to the semantic chaos variables we just discussed.
It either passes or it fails, no vibes involved.
Precisely. The rule is you force the code to prove it can pass the deterministic basics before you spend a single compute token waking up the AI. You do not ask a large language model if a file compiles, you ask the compiler.
So instead of a single massive border crossing where one totally overwhelmed AI guard tries to check every single bag in a 10-mile line of cars, we are setting up a series of small, highly specialized pull booths.
That's a great analogy.
And crucially, we're using metal detectors, those deterministic checks, before we even bother asking the AI to open the suitcase. If the metal detector goes off, you reject the luggage automatically. The AI never even sees it.
You are actively protecting the AI from its own worst tendencies by structuring a rigid, predictable pipeline around it. Once the deterministic checks pass, you route the code into isolated checkpoints where the AI performs targeted reviews based on that strict five-step contract we broke down earlier. It is all about compartmentalizing the risk.
So what does this all mean when we zoom out? Because if you are building an AI pipeline right now, the takeaway here is completely countercultural. You shouldn't be trying to buy a smarter AI. You should be building a stricter cage. The future isn't about throwing better tools at an agent and hoping it figures it out. It's about meticulously constrained pipelines, strictly managed environments, and enforced workflows.
We have to stop treating these models like infallible, omniscient oracles. We need to start treating them like brilliant but highly distractible interns who require crystal clear instructions, zero ambient noise, and a rigid framework to succeed.
That makes total sense.
The intelligence of the system doesn't just live in the neural network. It lives in the scaffolding we build around it.
Well, we've covered incredible ground today. We started with GitHub's counterintuitive discovery that cleaner tools increase costs and degrade performance if you don't constrain the AI's focus.
Yep.
We broke down the five-step workflow that anchors the AI to the diff, forces it to generate a concrete question, gathers targeted evidence, minimizes the reading range, and ultimately programs a hard stop condition.
And we explored the alarming fragility revealed by Microsoft's Agent Evil guidance, demonstrating why user identities and file paths act as semantic noise, which necessitates an ironclad environment manifest for any legitimate benchmarking.
And we dismantled the traditional merge gate in favor of deterministic checkpoints and isolated reviews.
But before we sign off, there's a final piece to this puzzle, a glimpse into the very near future of agentic architecture.
Okay, I'm listening.
If we've established how to make an AI gather targeted evidence and navigate a sterile environment, the next major frontier is an internal battle within the AI itself. I want you to consider the dynamic of plan versus critique.
Plan versus critique.
Yeah. Imagine an architecture where the AI generates a plan of action, say a plan to migrate a database, but instead of executing it, a separate system forces the model to critically evaluate its own plan.
Ah, so it has to red team its own logic.
Exactly. It must find the flaws in its proposed steps, argue against its own assumptions, and refine the execution based on internal adversarial review before a single tool is used. It might realize during the critique phase that it forgot a rollback step. The question for the future of this space is, will this self-critique loop make agents infinitely more reliable, or will it trigger an artificial analysis paralysis where the system argues with itself endlessly in a computational vacuum?
An AI stuck in an internal existential debate about its own workflow. Fascinating. Well, thank you for joining us on this deep dive into the paradox of AI tooling. Keep questioning the pipelines you rely on, keep scrutinizing the systems around you, and remember, just because you hand someone a master key, it doesn't mean they actually know how to fix the sink. We will catch you next time.